we're gonna put a load on this guy. We're gonna take it up to about 500 psi. There we go. So we got a 500 psi simulating a load. We're at about 2 gallons a minute right now, and we're sitting at about 3 3¼ inches of mercury. Okay, so that's what we're going to call our point of reference. Yeah. Because remember we talked about some people will say low is better. Keep that in mind. Low is not always better. It's relative to your point of reference. Okay, so what we're going to do now is, if you look at your tank, things look good. This is what I would call a normal operating condition. Okay, so now what we're going to do is we're gonna.
There is some air in there.
Yeah, a little bit.
It's flowing.
Yeah, that's not bad. I would still call that normal for now. It's a little bit. You know what? There's a little bit. When we first started up, there was a little bit of air. There was an air slug from our last demonstration. So that's probably working itself out, eh? So slightly aerated, because I do believe that normal on this machine is typically 3.5 to 4. So anyways, right now we're gonna cavitate this. Okay. So cavitation is we're gonna start the pump. We're gonna put an inlet restriction. We're gonna put an inlet restriction on here. Now remember, a gear pump is anywhere up to 8 inches of mercury, and then we're out of manufacturer's recommendations. So you can see it's coming up slowly. Notice we've lost a little bit of pressure already. Our flow is still 2 gallons a minute, and we're coming up to 5 inches of mercury, so we're still inside of our normal operating parameters. So I'm just going to take this very, very slowly. We're up to about 5.5, 6. And listen, you want to listen to the pump too, right? Notice the reservoir is not changing much. Cavitation really doesn't affect the reservoir, or if you'll notice, it's not affecting our pump outlet either. Everything's coming, it's drawing that 10% of saturated, 10% of the weight of the oil is dissolved air, depending by volume. But once it we're putting such a vacuum on it that it's actually drawing that air out of the oil, and that's what's going to be collapsing across your high pressure side. Yep. So we're up to about 8.5.
That means more restriction on the inlet.
Yeah, we're starving that. We're simulating a plug breather, overspeeding our pump, a plug inlet filter.
Basically, we're not giving the pump enough oil.
That's right. That's right.
For it to fulfill its responsibility.
So right now, if I was an operator, I'd be a little bit concerned, because if I knew my gauges, if I knew my system, I knew I was supposed to be at 500, and as soon as any operator sees a little bit of a bounce, you start saying, yeah, what's going on, right? But I don't think we'd be seeing a speed issue right now. He wouldn't be complaining of any speed issues, because we're still at 2 gallons a minute. Okay? But we might have a force issue because we're not at 500. We're not at 500 psi. We might not have our optimal force, right?
When you see needle bouncing like that, it's not solid liquid or solid air. It's a combination of the two.
Yeah, something's going on. If I see a bouncing needle here, if I was an operator, I'd be like, yeah, something that wasn't like that yesterday. Kind of thing.
You got air in your liquid or liquid in your air.
Yeah, well, you'll see. I'll ask you again in about 5 minutes which one's worse. Because when we aerate, you'll see quite a bit of a difference. Okay, so look at our inlet side. Our inlet side, something's definitely going on there. But you notice our reservoir. So a lot of people might think we're drawing air in from the reservoir. Our reservoir is looking air. No, it's not. We're not getting our air, so to speak, from aeration, from any air coming into the reservoir. It's actually coming out of the oil that's in the reservoir. So when it comes through and it comes across the high pressure side of the pump, it goes from low pressure to high pressure, bang. Once we're over atmospheric pressure again, once it comes back into the 450, it's back inside, it's back dissolved, you're saturated in the oil, right? The oil is saturated, I guess you'd say. Okay, so what are we at? We're at 13. Let's go a little higher, and let's see if we can get our flow. So you notice our flow is coming down. Our flow is coming down. We're at about 1.9, 1.8, a little fluctuation. I don't know if he'd be complaining about speed. Not real sure at this point, but I would be complaining. I know he'd be complaining about power, because we've lost about 100 psi. Yeah. So he's not going to see anything. If he looks inside his reservoir, he's not going to see anything through his sight glass. Right. So this is pretty much damaging the pump, and once the pump comes apart, like I said, it's coming downstream. It's going to create heat here. It's going to start coming apart, and it's going to take out. It's going to look down line, and it's going to say which components can I take with me, kind of thing. Right?
So to see some of those bubbles not dissolving again.
Yeah, a little bit, not much. And we're up to 14 inches of mercury, and we're down to about 1.8 gallons a minute. Or sorry, 1.8 gallons a minute. So you know what? That's basically cavitation. But what I want the highlight for me is it's not really affecting our reservoir, and it's not really affecting the purpose of the oil. I can still transmit power. I can still cool, lubricate, and seal because this is not really effective, so to speak. Okay? It's limited. You know what I mean? So let's kill this and let's try and get back to our...
And the oil temperature's going up too.
Yes, you betcha. We're creating heat. Now check this out. Basically, maybe in the field I changed the breather. Maybe the operator noticed he had a breather problem. He changed the breather. Watch how fast this. You know, maybe we slowed our pump down. Maybe we were overspeeding. We slowed it down. Maybe we changed the breather. We made the repair, and now look at your reservoir was never really affected in the first place. So, but look how fast this cleaned up. So cavitation is pretty easy to fix, right? You fix the breather, you replace the breather, you clean it, you slow your engine down, you do whatever it takes to fix the starvation issue, and bang, you can see this coming down. And once we're at our point of reference of about 4, that's back to normal kind of thing. So our next one,
GPM comes up also.
yeah, you bet. We're back up to 2 gallons a minute, and because the oil's warming up, like you said, George, we're going to get back to our 500 psi load, right? Our system pressure.